Okay, so today's lesson, we'll start by talking about square roots. So the square root of a number is one which, when raised to the second power, produces the given number. Then the square root, for example, of 25, if we write it like this, okay, so if we were to write the square root of 25, it would be equal to 5. Reason being is because 5 squared is equal to 25. Similarly, if we were to find the square root of 81, that would be equal to 9, and the reason being is because 9 squared is equal to 81. 9 times 9 is equal to 81. Okay, but most numbers, they don't have exact square roots. We can only get the approximate value for their square roots, and those numbers are called irrational numbers. Reason being is because they are non-terminating, meaning they don't ever end. They're non-repeating. They don't ever repeat their digits. So non-terminating, non-repeating decimals are called irrational numbers. So for example, if you put square root of 29 in your calculator, we end up with this number, 5.385165, and it continues on forever. It never ends, and also the digits never repeat. All right, so that would be an irrational number. A square root of 73, you end up with a number like this. And again, it never ends, never repeats, therefore irrational number. Pi is another example of an irrational number. You have a never-ending number, and it never repeats, so therefore irrational number. Okay, so I'll give you guys these ones to try. Okay, so just using our calculators, take the square root of 225. That gives me an answer of 15. Therefore, this is a rational number. For this example, we take the square root of 1024. That gives me 32. Therefore, it is a rational number. Take the square root of 3981, and we end up with a number 63.095166, and it keeps going, and it's not repeating. Digits are not repeating. It's never ending, so therefore this is an irrational number. All right, so just again, the definition of irrational numbers: they are non-terminating, non-repeating decimals, and they do not have the exact square roots. We can only get the they don't have the exact square roots like we saw here and here, so therefore it's an irrational number. So next we're looking at calculations using the Pythagorean theorem. So a squared plus b squared equals c squared. C is the hypotenuse. A represents altitude, b represents base, but like I said, the a and b, if they got interchanged, that's okay. It's the hypotenuse, that is the c. So calculate the hypotenuse of a right angle triangle where the base is 16 centimeters and the altitude is 12 centimeters. So this is what our triangle looks like, and we need to calculate the hypotenuse there. So let's put our formula down. Okay, so for A, we'll use the 12 squared. For the B, it is 16 squared, and that'll give us c squared. So you can put that into your calculators. So 12 squared, that is 144. 16 squared, that is 256, which will give me c squared. Add those two together, that gives me 400. Okay, that is what c squared is equal to. So we still have to figure out what c is equal to. So the last step is taking the square root of both sides. The square root of 400 is 20, and now we have the answer for c. So therefore 20 centimeters is equal to c here. All right, so to solve for this one, we have find the length of the altitude of a right-angled triangle where the base is 7 kilometers and the hypotenuse is 25 kilometers. So we need to solve for A. Okay, so our formula is A squared plus B squared equals C squared. So if we're solving for A squared, that means we're subtracting the B squared on both sides. All right, so therefore our formula will be A squared is equal to C squared minus B squared. All right, so I'll just rearrange the formula. So A squared will be equal to 25 squared minus 7 squared. 25 squared is 625. And then 7 squared is 49. So we'll subtract those two to give me 576. Okay, that's still for A squared. We need to solve for A. So now we take square root of both sides to give me A is equal to 24 kilometers. Okay, so for the first example here, we have a side as 112 decimeters. We have this side as 66 decimeters. Here's our right angle, and directly across from it, this would be our hypotenuse. So therefore, we are solving for our C in the formula. So A squared plus B squared is equal to C squared. Okay, so 112 squared plus 66 squared is equal to C squared. So put those both into the calculator and you should end up with 16,900 is equal to C squared. Square root then both sides to get C, and we get 130 decimeters is equal to C, which is our X. Okay, so just make sure that you do, because it does ask you to figure out X, so therefore X is equal to 130 decimeters. All right, our next example. Okay, so for our next example, again, find your right angle. It's right here, so therefore this is our hypotenuse. So we're solving for one of the sides or one of the legs. All right, so when we rearranged our formula, let's say A squared is equal to C squared minus B squared. Okay, so A squared is equal to 178 squared minus 160 squared. Put that into your calculator. And I get A squared is equal to 6,084. So next we have to take the square root of that. And I get that A is equal to 78 kilometers. But again, we're solving for X, so make sure we do put that X is equal to 78 kilometers. All right, so for this example, calculate the length of a rectangle with the following measurements. The diagonal measures 7.5 meters, so there's our diagonal. This is 7.5 meters. And the width here is measuring 4.5 meters. And this is the length here that we need to solve for. I'll just call it L for length. Okay, so now we can see we have the two right-angled triangles. So we have the hypotenuse, we have one of the legs, we need to solve for the other leg. All right, so B squared is equal to C squared minus A squared. So B squared is equal to 7.5 squared minus 4.5 squared. So put that into your calculator. 7.5 squared minus 4.5 squared. One sec. Okay, so then we would just take the square root, and we end up with b is equal to 6. So therefore, the length is equal to 6 meters. So in this example, we have a triangle. If you look at the solid lines, it is not a right angle triangle. So we are told that AB is 13 centimeters. So I'm just going to label that 13 centimeters there. B to C is 21. So I'm just going to kind of show it like this. B to C is 21 centimeters. And then BD, so B to D, here to here, that is 5 centimeters. And we need to calculate the length of AC. Okay, so in this example, we've just finished labeling all the different sides of the triangle. So A to B is 13, B to C is 21, and then B to D was 5 centimeters. And then we need to figure out the length of A to C. So I've just redrawn this triangle here, this one here, so that we can solve for AC. So because we can take 21 centimeters and subtract the 5 centimeters, we would get the length of D to C. All right, so I'm just going to show that I did 21 minus 5, which is equal to 16 centimeters. All right, so D to C is 16 centimeters. So we need to solve for A to C. That's what we're solving for, but we don't have this side. We need to have a second side to be able to solve for our third side. So we have to use this small triangle here and solve for AD because we do have two measurements there already. So let's do the small triangle. I'll just redraw it like this. All right, so we have here, it is 5 centimeters. Here is 13 centimeters. This is the AD. So let's solve for that side there, and it's a shared side. So therefore, it would also be the same measurement for AD there. All right, so it's a side. It's one of the legs. So we already have the hypotenuse and we have the base, so we're solving for altitude. So A squared is equal to C squared minus B squared. So therefore, 13 squared minus 5 squared, that gives me 144, square root both sides, and that gives me 12 centimeters. All right, so therefore, A to D here, we just solved for, it is 12 centimeters. So I'm just going to add that here, that it is 12 centimeters. Now if we look at our triangle, this is our right angle right there. We are solving for the hypotenuse AC. So now we can go ahead and solve. A squared plus B squared is equal to C squared, or AC squared. So 12 squared plus 16 squared. Okay, put that into the calculator, and we get 400 is equal to C squared. And then we have to take the square root. Square root of 400 is 20. So 20 is equal to C. And then make sure we do answer the question, which is to calculate the length of side AC, which we were just using as C. So AC is equal to 20 centimeters. So our next example, calculate the height of an equilateral triangle whose sides are congruent to 10 centimeters. So that means when we draw our diagram here, all three sides are the same because it's an equilateral triangle, and the sides are 10 centimeters. All right, so that's 10 centimeters, this is 10 centimeters, this is 10 centimeters. All right, but look at our angles here. Are these right angles? Okay, but we are looking for the height of this triangle, so our height, I'll just show as a dashed line going down like this. Now we have created a right angle triangle. All right, so we have here the hypotenuse, right? Because there's our right angle. This would be our hypotenuse. We have to figure out the height. What would this side here be? If we've split it down the middle, we know the full length is 10. Yes, that's correct. So we are going to label those two sides as 5 centimeters. Now we can calculate for this side here, the height of that triangle. All right, so if I just redraw it like this, just showing it here, this is what we have. This is 10 centimeters. This is 5 centimeters. This is what we're trying to solve for. Okay, it's one of the legs. This is our hypotenuse. This is one of the sides. Let's just call it A. Okay, so I'll let you guys solve that. All right, so solving for A then, we have our hypotenuse. It is 10 squared. So let me just write out the formula. So our hypotenuse, so 10 squared minus our base squared, so 5 squared. That gives me 75. Okay, and then we have to square root both sides, and that gives me 8.66, and it's going on 0.25 and so on. So we will just round to the nearest hundredth, so 8.66 centimeters. Okay, so therefore the height, which is what we just solved for, the height is 8.66 centimeters. All right, so we'll stop here. Okay, so for this example, we have a rectangle, and we're told that the perimeter of the rectangle, so the perimeter, is 98 centimeters. And just note again, perimeter is just the length of the outside of this rectangle. So total length of the outside. One of its sides is 9 centimeters, so 9 centimeters. And we have to figure out the length of the diagonal of this rectangle. So from here to here, that's the diagonal, and we've just called it x. So the first step we have to do here is figure out this length before we can figure out x, because we need to know two sides before we can use the Pythagorean theorem to solve for the diagonal. So we're going to use our perimeter formula. P equals 2L plus 2W. And we're solving for length. Sorry to do this. We already know our perimeter, it's 98. And we're solving for length, and we know our width, it's 9 centimeters. All right, so we're just solving this. 98 equals 2L plus 18. And now we're going to continue to solve for L. So we're going to subtract 18. Subtract 18 on both sides. And that will leave me with 80 is equal to 2L. And lastly, we'll divide by 2. And that gives me 40 is equal to L. So 40 centimeters. All right, so now we can put that 40 centimeters here. Now we have two sides. So now we're able to solve for the third side. So the second part, so this was our first step. And our second step now will be to use our Pythagorean theorem. So here is our right angle. Therefore, this is the hypotenuse. So we're solving for the hypotenuse. So a squared plus b squared is equal to c squared. 9 squared plus 40 squared is equal to c squared. And when you just put that in your calculator, 9 squared plus 40 squared, 1,681. That is equal to c squared. Then we have to take the square root of both sides, just like that. Put that in your calculator. And it's equal to 41 centimeters is equal to c, which was equal to x. So that is the final answer of what we were solving for, which was the diagonal of that rectangle. All right, so we're solving for this side here of the triangle. We know the hypotenuse, and we know one of the legs of this triangle. So we have to solve for the second leg. It's the base. So b squared is equal to c squared minus a squared. So 6.25 squared minus 3.75 squared. Okay, so when you put that into your calculator, you should get b squared is equal to 25. And then you would take the square root of both sides to give us b is equal to 5 meters. So a fastball diamond is a square, and the distance between each base is 25 meters. Find the distance from second base to home plate. So we've already worked on the diagram here. So we are looking for this diagonal. Okay, and because it's a square, we know that all sides of the square are 25 meters. So this here would be 25 meters as well. So now we have our right-angled triangle right here. We are solving for the hypotenuse. All right, right across from the right angle is our hypotenuse. So a squared plus b squared is equal to c squared. So 25 squared plus 25 squared is equal to c squared. Okay, so let me just put that into my calculator. That gives me 1,250 is equal to c squared. Remember to take the square root of that. And we get 35.3553. So we just round that to the hundredths. So we round it to 35.36 is equal to, well, x is what we called it. And make sure we use our units there. It is in meters. All right, so we'll stop there for today.